Hey, it's Daryl from the Pixel Farm, and in this video I'm going to give you an example of how you can use PFDepth to perform automated stereoscopic conversion without drawing a single rotoshape. Okay, so here's a shot that we're going to work on. I'm just going to select that and play it back so you can see what's happening. Now there's a lot of occlusion, a lot of organic material, so a pretty difficult shot to work with. But I'm going to show you how quickly we can do this in PFDepth. I'm just going to select it and make some basic adjustments. For example, the film back, I'm going to accurately represent the imaging sensor of the camera that shot it. And I'm going to import an FBX. I tracked this camera in PFTrack, and that gives me a lot of useful information. Not only the tracked camera, but if I bring it in as an FBX, I also have the 3D point projections from the point cloud. And this is an RGB point cloud. You can see we've got our camera path, we've got our point projections, so we now have depth cues of where these different objects live in Z-space relative to the camera's position frame to frame. And that's unique with PFDepth. Everything's based on world space. So now I'm adding a Z-depth solver node, and we're just going to go ahead and solve this, and this creates our depth map completely automatically based on those depth cues. I'm just fast forwarding this for the sake of time, but you can see what we've got here. The next thing we're going to do is add a Z-depth merge node, and this allows me to take that initial depth map and refine it. It's going to do some analysis frame to frame and try and smooth out some of the randomness that might be occurring. And we can see here we now have that refined depth map. Now it's not perfect. You can see here we've got some black spots here on the left-hand side, and we're going to use the Z-depth edit node and the erase brush literally to start poking holes in this. What we want to do is get rid of some of those spikes, some of those Z-depth errors that have been created, and we can see we've got some over here that's pulling the depth map forward. We're doing this really quick. We're not getting intricate with it or anything. We're not doing any detailed depth painting. I'm literally just poking holes in this. A few more up there, and once we've done that, we can see the frames that we have those holes poked. The next thing we want to do is fill in the blanks. So I'm switching over to the Fill tab. We're going to select the entire clip and say Autofill. And now it's going to use the pixel information around each one of those holes to effectively fill in the blanks. So again, really, really quick results. We're not getting intricate with selecting different regions, trying to do detailed depth painting. PFDepth is doing all of the hard work for us. The next thing to do would be to add a stereo render node. This is going to allow us to see what the result of our stereopsis is, and we're just going to increase the disparity scale. I'm going to amplify that just for the sake of display. And right now we're looking at it as an anaglyph, but I could also use NVIDIA's 3D view technology to look at this using active shutter glasses on secondary monitors. So there you have it, almost completely automated stereoscopic conversion using PFDepth without drawing a single rotoshape. For more information on PFDepth, please visit the website at www.thepixelfarm.co.uk.